So we have all defined insolation. Now we will be coming to the factors which affect insolation and the distribution of insolation. First of all, we will come to the distribution of insolation. Now, as we can see here, the distribution of insolation differs in differing latitudes. So these, at 0 degree, the equator, insolation is 100. As we move up, it decreases. 10 degrees, 99. 20 degrees, 95. 30, 88. 40, 79. 50, 68. 60, 57. 70, 47. 80, 43. And at 90 degree North Pole, it is 42. So when we compare 100 at the equator and 42 at the poles, so definitely it's much lower in the poles. And insolation is also based on seasons and also the time periods, meaning in different seasons insolation is different. The amount of insolation received by a place, if the place is experiencing winter, insolation will be lower. If the place is experiencing summer, insolation will be more. And during the time periods where there is a lot of turbulence in the atmosphere, weather phenomena, clouds, then insolation is lesser. When there are clear skies, insolation is much higher. Now we come to the factors which affect insolation. So we have the factors which affect insolation. Among the factors, the first factor is angle of the sun's rays. Angle of the sun's rays. Let us have this. Let us have a look at this simple diagram. Suppose this is the earth and this is the sun. The sun's rays falling on the earth's surface vertically overhead at a place called A, and the sun's rays falling on another place called B at an inclined angle called B. Okay, now we will see the distance between the sun and the place A and the sun's rays and the place B. B will be definitely more, A will be shorter. So the insolation received at A will be more than B. Now this is another reason. Suppose this is the place, this is the land on which the insolation is falling. When the sun's rays falls vertically on the place, the area which is to be heated, it is much smaller than when it is falling at an inclined angle where the area becomes bigger. Okay, this is the rays, it becomes bigger. This is the ray, it's smaller. The area which is heated is smaller and the area which is heated becomes bigger. Okay, so this is the reason why insolation will be more when the sun is overhead the area than when the angles are falling at an inclined angle. Okay, now the second is length of the day. Now we have different lengths of days during different seasons. In winter, days are shorter. In summer, days are longer. Now when do you think insolation will be more? Definitely when the days are longer, because the period of heating by the sun, activity of the sun's heating will be longer in the summer than in the winter. So insolation is more in the summer season than in the winter season. Now third, it's distance between the earth and the sun. Now it seems to us that the earth and the sun are at equal distance all throughout the year, but there are two periods in a year. One is in 3rd January, where the sun is closest to the earth. That phenomena is known as perihelion. It is at a distance of about 147 million kilometers. And another period when 4th July, when the sun is farthest from the earth, this phenomena is known as aphelion at a distance of about 152 million kilometers. So insolation will be more during perihelion, and insolation will be less during aphelion. But during 3rd January, southern hemisphere experiences summer because it is inclined towards the sun. So the summers in southern hemisphere are much hotter than the northern hemispheres. Now next, we come to the next factor, another important factor, that is sunspots. Now what are the sunspots? Suppose this is the sun. In the sun, there are particular areas where there are disturbances or explosions which take place, and because of these disturbances and explosions, the insolation increases. Okay, the insolation increases when there are more sunspots, insolation decreases. When there are lesser sunspots, this is said to occur over a period of 11 years interval. At every 11 years interval, the sunspots are the highest, then it goes down slowly, then again it comes. So whenever the sunspots are more, then insolation is more. And the fifth and the last factor is transparency of the atmosphere or the conditions which are prevailing in the atmosphere. In the last class, we have seen that the atmosphere envelopes the earth. Suppose this is the atmosphere, this is the earth, and this is the sun. The sun's rays, if it has to reach the earth's surface, it has to pass the atmosphere. And different weather phenomena which take place in the atmosphere, especially in the troposphere, some parts of the stratosphere, the clouds, dust particles, water vapors, their presence disturbs the penetration of sun's rays to the earth. So when there are more clouds, more dust particles, more water vapor, then insolation is less. When there are clear skies, then insolation will be more. Okay, so these are the important factors which affect insolation. Next we will discuss about heat budget.